Hello students, welcome to this video on linear momentum and collisions from tutorial sheet 5 of the University of Zambia PHY 1015. In this video, I'm going to be working out questions 5 and 6 from that tutorial sheet. In the previous video, we worked out questions 3 and question 4. So this is the tutorial sheet we're looking at. So we answered question 3 and we also answered question 4. So in this video now, we're going to look at question 5 and question 6. So just go through the questions. So I hope you have your tutorial sheet with you. I'm just going through this just in case. So we'll start by looking at question 5. So when you look at question 5, and then when you read through, I always advise you to read the question at least twice. So what you're doing with the first time when you're reading the question is you're trying to understand what the question is asking you. What is the question telling you to find? Once you know what you're looking for, then you can read through the question now, obtaining the information the question actually is giving you. Then you can use that information to calculate what you need to calculate. So in this case, when you read through, we're saying a 23-gram bullet traveling at 230 meters per second penetrates a 2 kg block of wood that emerges cleanly at 170 meters per second. If the block is stationary on a frictionless surface when hit, how far does it move after the bullet emerges? Now, there's a slight correction to the question. In this case, if you try to analyze the way the question is, we're saying you have a bullet that is fast moving, it hits a block, and then comes out from the other side of the block. Now, what you have to notice is the block is on a frictionless surface. So if the surface is frictionless, it will mean that it is going to keep on moving unless if acted upon by an external force. Of course, that is from Newton's first law of motion. Now, if that's the case, then it becomes very hard for us to find how far it moves. How far does it move after the bullet emerges? That becomes very, very hard for us. But when you look at the answer that is provided in the bracket, you will notice that it's actually a velocity. So it's like, since we know the velocity of the bullet before collision and the velocity of the bullet after collision, it only makes sense that the question is asking us to find the velocity of the block after the bullet emerges. So it's the velocity of the block after collision that we need to find in this case. Now let's quickly try to see how we can find this velocity. Okay, so I hope you're ready and I hope you tried it. So yeah, if you haven't, you can just pause the video and try it. Try to find the final velocity of the block after collision. If you've tried it and you just want to confirm, right, then just hold on. Okay, so I think we can start working at that question. So we're looking at question 5. So now in this case, if you've read through the question, now we can start getting the extracts, what the question is really asking of us. So this is question 5. Okay, now from the first part, we're saying a 23-gram bullet. So I'll use small letter B for the bullet and capital letter B for the block. So this is a bullet of mass M, small letter b, 23 grams. Now, if we convert this to kgs, this becomes 0.023 kgs. Then apart from that, we're saying it is traveling at 230 meters per second. So that is the initial velocity of the bullet. In other words, the velocity of the bullet before collision. So V for the bullet initial or before collision, this is equals to 230 meters per second. Okay. Now, apart from this, what else do we have? Next part, we're saying it penetrates a 2 kg block. So we're saying we have a block now of mass M, capital B, this is for the block. this is 2 kg, so there's no converting here. And then, so that's a 2 kg block of wood, and it measures cleanly at 170 meters per second. So the final velocity of the bullet, that's VB final, is equals to 170 meters per second. Okay. All right. Now, if the block is stationary on a frictionless surface, so it means that the initial velocity of the block, since they're saying it was stationary, is 0. Now we want to find the final velocity of the block after collision. This is what we want to find. Okay. Now let's see how we can do that. So here we have to conserve momentum. So we're saying the momentum before collision and after collision, they must be equal. So we're saying the mass of the bullet multiplied by the velocity of the bullet initial added to the mass of the block multiplying the velocity of the block initial. These must be equal to the final velocity of the bullet, the mass of the bullet is still the same, multiplying the final velocity of the bullet final added to the mass of the block multiplying the final velocity of the block. Okay, now this is the conservation of momentum, and since from here we're saying VB initial is 0, implying that this term will be 0, and when we see what we're remaining with, the equation is now MB VB initial is equal to MB VB final plus MB VB final. Okay. So what we want to find is the VB final. We want to find this term here. So we're just going to make it the subject of the formula, and then we're going to do our substitution there. Okay. Now, how is it going to look? So this term here, the second term, the first term on the right-hand side, going to cross the equal sign. So this becomes MB VBI minus MB VB final is equal to MB VB final. Okay, nice. Because from the left-hand side, we should see to say that since the mass is common, we can just say that, okay, this is MB. So you just have to get the difference in the velocities, VBI minus VB final. And then this is what is equivalent to MB VB final. Okay. Now we want VB final only here. So we're going to divide through by MB. This is now going to be MB VBI minus VB final divided by MB. This gives us the final velocity of the block after collision. Now we can perform our substitutions. So remember, the mass of the block in kg, not of the block, sorry, of the bullet in kgs, this was 0.023 kgs. The velocity initial of the bullet, if you remember, that's velocity initial of the bullet, that was 230 meters per second. And the velocity final of the bullet, this was, that was 170 meters per second. Okay. And then lastly, the mass of the block, hope you remember, 2 kgs. Nice. Now we can perform our substitution. So here I have the left-hand side and the right-hand side. I can just switch them. Still haven't changed the thing. So V block final is equals to the mass of the bullet, 0.023, open bracket, the velocity initial of the bullet, that's 230, sorry, minus 170. This must be divided by 2. Okay, so you can try out that that calculation and see if it gives you what we expect. Okay, so if I just work it out here as well. Okay, so that's 0.023, and then we have 230 minus 170. Okay, so this gives us that, then divided by 2. Okay, 0.069. Okay, that's exactly what we expect. So that is 0.69. So never forget the units, that's velocity. So this is meters per second. Okay, as expected. Nice. So thumbs up if you did manage to find it as well. All right, now we can move to the second question. So if you recall, the second question is talking about a 75 kg ice skater moving at 10 meters per second who crashes into a stationary skater of equal mass. After the collision, the two skaters move as a unit at 5 meters per second. Suppose the average force of a skater can experience, the average force a skater can experience without breaking a bone is 4,500 newtons. If the impact time is 0.1 seconds, does a bone break? Okay, now for this question, we've seen, like, first you have to understand what they're asking you to do. After you know what they're asking you to do, then you can look at, okay, how can I use the information that I've been given to actually achieve that? So this is question 6 from the tutorial sheet. Now, let's look at what we've been given. First, we're saying the mass 1 of the skater 1 is the same as the mass of the skater 2, and it is all 75 kg. So the mass is the same. And apart from that, we're saying M1, the skater number 1, at the velocity v1, which was initially 10 meters per second in one direction. And then the second one, v2, was initially at rest. So after collision, v1 now has a velocity of 5 meters per second. Of course, it's the same as this one, since they move together after collision. Okay. Now, after that, then the question goes on to say, suppose the average force a skater experiences without breaking a bone. So they're giving us a condition for a bone to break. What's this condition? So they're saying, if a skater experiences a force of about 4,500 newtons, then a bone is going to break. So this is a condition. But if the force experienced is less than this, then most likely the bone is not going to break. Now, we need to find the force that this skater experiences. Now, look at the information that you've been given. This so far doesn't help us to find the force. We need some more information. Now, look at what follows. Look at what follows. So now they're saying, if the impact time is 0.1 seconds, that's a bone break. Now that they've given us the time. So if you recall from Newton's second law of motion, force is equals to ma. So this is one way you can work on it to find the answer we're looking for. But if you don't want to use this approach, you can still use momentum. Since the topic is momentum, you can still think about force. Where does force come in under momentum? It comes in under impulse. Remember, impulse is equals to two things. In one way, impulse is equivalent to the force times the change in time. Apart from this, impulse is also equivalent to the change in momentum. Okay, now we're going to use this part. So what we're saying now, force is equivalent to the change in momentum over the change in time. Now, both formulas are going to work. They can give us the same answer. Just up to you which one you prefer. Now, let's start with the first one. So the first one is from Newton's second law of motion, F is equals to ma. So if you look at this, we already know our mass, that's 75 kg for each. But then we need the acceleration. So you can create the acceleration or the deceleration, that's fine. Now, we have to go back to the information that we were given earlier. So it doesn't matter which one you pick, the answer will still come out the same. Let's pick the first one. So for the first one, if you look at what is happening, he starts with one velocity. We're going to use this information for the first one. the velocity changes from 10 to 5 meters per second. Remember the time we're given? This happens in 0.1 seconds. So since we know the final velocity and the initial velocity, we can then find the time, the deceleration or the acceleration. So the mass, remember, the mass, we just found it, actually it was given in the question. So F is equal to the mass, 75 kg. That's 75 kg, multiplying the acceleration. What is acceleration? So acceleration, the formula is final velocity minus initial velocity over t. So if we substitute that, or if we actually work it out, final velocity is 5, initial velocity is 10, time taken is 0.1. So if we work this out, that's minus 5 over 0.1, which gives us a 50 minus 50 meters per second squared as our acceleration. So if we substitute this in the second row, that's F is equals to 75 times negative 50. Okay, so then we calculate this. So we're looking at 75 times 50. This gives us 3,750. That's 3,750 newtons. Of course, the negative just means that the force is in the opposite direction to direction of motion. Okay. Now, the second way in which you can do this is using momentum, this part. So the change in momentum, how do we calculate this? So this is the mass. So again, we just have to pick one skater here. You don't have to look at both of them, just one of them. How is the change in momentum for one of them? Because the force he experiences will be equivalent to the force the other one experiences. Okay, now how do we do this? So we're saying M, whatever, you can say M1, the final velocity of M1 minus the same M1, the initial velocity of M1 over the change in time. Okay, from here, notice that the mass is the same, so it's the same scatter. So that's M. And then you have V final minus V initial over T. Now I want you to notice that this term here, it actually just gives the acceleration. So this, in a way, takes us back to the second law of motion. So we really expect the same answer as well. So if we substitute, this is 75, the mass, and then the final velocity is 10, sorry, that's 5 minus 10 over time 0.1. Again, this gives us, when you multiply this gives you 50. When you multiply again, just as we saw this side, this gives us a 3,750 newton. Of course, a negative, which only implies that we're going in the opposite direction. Okay. Now, it doesn't matter which approach you take, it's to give you the same answer. But now, to answer our question, the question was, if the impact time is 0.1 seconds, does a bond break? Remember the condition for a bond to break? We're saying the force of impact must be equal to 4,500 newtons. If this is the case, then the bond is going to break. But we've just seen that the force this skater will experience is 3,750 newtons. This force is definitely less than the required force for a bond to break, implying that in this case, no bond will break. So the bond will not break. So our answer is no. The bond will not break. Not break. Okay. So with this, we're done with question 6. Now, students, I think this is what all we'll do for now in this video. The next video is going to look at question 7. Question 7 is a little bit long, so it's going to have an entire video on its own. Hopefully, I'll be able to upload it by the end of the day. So look out for that. So if so look out for that. I'll send the links in the groups. Yeah, so for those who have subscribed, once the video is up, you'll be able to see the video as well. All right, so thank you very much for paying attention, for sparing the time to see the video. I hope it was helpful. If you have any other questions that you'd like me to work out that maybe are giving you problems, you're failing to get over them, of course, I'd advise you to try them first. But if you struggle and your friends cannot help you, just get in touch with me in the email in the description below. I should be able to help you there. All right, thank you very much. Thank you very much. I hope you're keeping yourself safe. See you next time. Okay.